Assalamu alaikum wa rahmatullahi wa barakatuh. This is the second part of chapter 3 problems. And here he says, assume your mass is m, the mass of the earth is big M, and the radius of the earth is r. Which of the following equation represent your weight at the earth's surface? Your weight, which is the gravitational force here, equals big G times the mass of the earth times the mass of you divided by the radius of the earth squared. So this is represented by number A. I want to tell you something, that the weight on the surface of the earth is mass times the gravity, and the gravity here is 9.8. If you equate this side to the other side, let's remove this m with this m. That means there is an equation for the gravity on the surface of the earth, which is G times the mass of the earth divided by the radius of the earth squared. So this is equal to 9.8 meter per second square. So we might need this equation later. Again, G, which is the gravity acceleration at the surface of the earth, equals the big G, which we call it gravitational constant, times the mass of the earth divided by the radius of the earth squared. This amount is the 9.8 that we know. An astronaut has a mass of 100 kilogram. His weight is 327 on another planet. So he gives us the mass and he gives us his weight, but on a different planet. The gravitational strength on that planet is what? So we know that the weight is mass times gravity. On the earth, this is the gravity of the earth. On another planet, so the weight on other planet equals to the mass times the gravity on the other planet. The weight on the other planet, he gives it to us 327. The mass of the object is 100 kilogram times the gravity on this planet. So the gravity on this planet is 327 divided by 100 gives you 3.27 meter per second square. Of course, the gravity on the earth is 9.8. So G on this planet divided by G of the earth is 3.27 divided by 9.8 gives you almost 1/3. So the gravity of this planet is almost 1/3 the gravity on the earth. Three masses are located as shown in the diagram below. The distance between M1 and M2 is x1, and the distance between M2 and M3 is x2. If mass 3 is 4 times mass 1 and x2 equals 2 times x1, what is the net force on the mass M2? We need to find the net force here. So the mass M2, it's subjected to two kinds of gravitational force. A gravitational force toward M1, I will call it F1, and another gravitational force toward the mass M3, I will call it F3. So I need to find F1 and F3 and subtract F3 minus F1 to get the net force. Let's start with F1. The gravitational force F1 is big G times the mass M1 times the mass M2 divided by the distance in between squared, which is x1 squared. Okay. Then the second force, F3, it's the big G times the mass M3 times the mass M2 divided by the distance in between squared, which is x2 squared. But let's remember that he said M3 is 4 times M1. So I can remove M3 and write 4 times M1. And also he says x2 is 2 times x1. So I can remove x2 and say it's 2 times x1, but take care that this one is squared because there is a square here. So let's substitute and rewrite it again. So it's g times 4 times m1, 4 times m1 times the second, which is m2, divided by x2 square will be 2 times x1 total square, which we can write it as 4 times x1 square. 4 times x1 square. So we can remove the 4 with 4. So the leftover here is g times m1 times m2 divided by x1 square. So this is the final value of f3. Look at the first equation, f1. Look at this equation for f3. And we need to subtract them from each other. But if you look, they are equal. So the net force is 0. So I will choose 0. A rifle with a mass 1.2 kilogram fires a bullet of a mass 6 grams or 0.006 kilogram. The bullet moves with a velocity 600 meters per second after the rifle is fired. If the external forces acting on the rifle can be ignored, what is the recoil velocity of the rifle? As you know, if there is a rifle, and this rifle has a bullet inside, once you pull the trigger, there will be an explosion in the powder here, which pushes the bullet forward with a speed v, which is here 600 meters per second. At the same time, if you hold the rifle in your hands, you will feel that the rifle pushes you back because of its recoil velocity. Okay? So it pushes you back with a certain velocity VR. So I will call the velocity of the bullet VB and the velocity of the rifle VR. What's the relation between the rifle and the bullet? Actually, here it's the relation of momentum. The total momentum of the system before you pull the trigger, it was 0. Why it's 0? Because the rifle was stationary, doesn't move, and the bullet also was stationary. So the total system has 0 velocity. That means the total momentum of the system before you shoot it, it was 0. The bullet moves to the right, while the recoil velocity causes the rifle to move to the left. What is the relation here? The total momentum of the system after you pull this trigger, it must be 0. So the momentum of the bullet, which is to the right, minus the momentum of the rifle, which is to the left, must be 0. Meaning that the momentum of the rifle equals to the momentum of the bullet. So what is the momentum of the bullet after firing? After firing, it's the mass of the bullet, which is 0.006 kilogram. Take care that we cannot use it in grams. Times its velocity, which is 600 meters per second. And the momentum of the rifle equals its mass, which is 1.2 kilogram, times its recoil velocity. I will call it VR. So VR here is 0.006 times the 600 divided by the 1.2, which is 3 meters per second. So this is the recoil velocity of the rifle. An object of mass m and an object of mass 3 times m. So you have an object of mass m, another one 3 times m. Collide with each other as shown in the following figure. The lighter object, which is the one to the left, is initially moving twice as fast as the heavier one. So if the speed of the heavier one is v, so the speed of the lighter one is 2 times v. If the two objects stick together after the collision, meaning that they will have the same velocity after the collision, what would be their velocity? We need to find their velocity after the collision. If you remember, the total momentum before collision equals the total momentum after collision. So if I have two masses, A and B, mass A times velocity A at the beginning plus mass B times velocity B at the beginning equals mass A times the velocity of A after collision plus mass B times the velocity B after collision. So let's substitute in our diagram here. Mass A is m. The first velocity is 2 times v plus mass B is 3 times m, so 3m. Its velocity is v. No, it's not v, it's negative v, because it's moving to the left as seen here. So you need to substitute it negative v. So I will change this sign and make it negative. Okay, equals, after collision they have the same final velocity. I will call it vf because they stick together as he said here. So the first mass is m times vf plus the second mass is 3m times the same vf. If you add those together, it gives you 4 times m times vf. So if you look to both sides, you can remove the mass from all the sides. That means 2v minus 3v is 4 times v final. Of course, v is the initial speed, so 2v minus 3v, that's negative v, equals 4 times v final. So the v final is negative 1 over 4 times v initial. So this is the relation between the v initial and v final. So let's see, he says here, what would be their velocity? Negative here means the system will move to the left. The system will move to the left. So it's 1 over 4 to the left. It's not 1 over 4 to the right. It's not 5 over 4. It's not v. So I will choose the first one, 1 over 4v to the left. The two blocks are sliding on a frictionless surface as in the figure below. The block of mass m is moving at speed 2 times vi. The other block has a mass 3 times m and is moving at a speed vi. The lighter block collides with the heavier block and sticks. So they stick together, meaning that they will have the same velocity after collision. It's like the previous example, but the direction here, it's different. What is the speed of the two blocks after collision? Let's write the equation. The first momentum will be the momentum of this one. It's m times 2 vi plus the second momentum, which is 3 times m times the velocity, which is vi, and take care the two velocities here are positive because they are to the right, equals the total momentum after collision. They will stick together, so they will have a mass m plus 3m, which is 4m, times their final velocity. I will call it vf. So this one is 4 times m. Then we can remove the mass from all the sides. That means vf equals, here it's 2 times vi and here it's 3 times vi, gives you 5 times vi divided by 4. So it's 5 over 4 times vi. So I will choose the first one. The positive sign here means the system is moving to the right. He's asking about the speed, so it doesn't matter the sign, so it's 5 over 4 times vi. A rubber ball of mass 1/4 kilogram is dropped from a height 1.5 meter onto the floor. So we have a floor and you drop a ball. When you drop it, that means its initial velocity here is 0. You drop it from a height 1.5 meters. After bouncing from the floor, so it rebounds back after it falls down. It hits the floor with a certain speed, I will call it v, and then rebounds back with another speed, I will call it v2. Let's call this one v1 and the other one v2. So it rebounds, or after bouncing from the floor, the ball has a speed 4 meters per second. So it rebounds back from the floor at a speed 4 meters per second. If the average force of the floor, the average force coming from the floor, is 18 Newton, how long is the ball in contact with the floor? Find the time of the collision here between the ball and the floor. Assume all friction forces are negligible, like we will forget or we will neglect the friction forces. We need to find first the speed v1. You dropped the object from a height 1.5 meter at an initial speed 0. So that's a free fall under the gravity. So you need to find its final speed before it hits the ground. We can use the equation v square equals v initial square plus 2 times g times h. The third equation of motion with constant acceleration. V initial is 0, the g is 9.8, the height is 1.5 meter, so I can find the velocity v, which I call it here v1. Okay, so I call it here v1. It's the root of 2 times g times 1.5. It's the root of 29.4, which is 5.42 meter per second. So this is the speed of the object, and it's downward, of course. So the velocity of the object before it hits the ground, it's 5.42 downward. The object rebounds because of the collision. So here I have the force that acts on the object. I have the initial speed of the object before it hits the ground. I have the rebounding speed. I need to find the time of collision. So I can use the equation of impulse and momentum. The force times delta t equals the change in momentum. The momentum is m times v2 minus m times v1. What's the positive direction of this equation? Let's take the upward to be our positive direction for this equation. So the force will be positive 18. The time is delta t. The mass of the object, he gives us 0.25 kilogram. We can take it common factor. Times v2 is positive because it rebounds back upward. So it's 4 minus. v1 is negative. So minus minus will be positive. So it's plus 5.42. From here, the right hand side, let's try to calculate it. 4 plus 5.42 times 0.25, it's 2.355. That means delta t is 2.355 divided by the force, which is 18. Gives you 0.131 second. So the time of collision here was almost 0.13 second. So I will choose number A. In a head-on collision, a car stops in 0.1 second from a speed 14 meters per second. The driver has a mass 70 kilogram. Fortunately, tightly strapped into his seat. What force is applied to the driver by his seat belt during that fraction of second? So the information here, we have a head-on collision. The time of this collision was 0.1 second. The initial speed of the object was 14 meters per second. That's the initial speed. What about the final speed? The final speed is 0 because the car stopped after the collision. The mass of the driver is 70 kilogram, and we need to find the force from the seat belt on the driver. We can solve this problem by two methods. The first method is from the time and the initial speed and the final speed, we can get the acceleration, and then we use Newton's second law, force equals mass times acceleration. Let's try this one. I have the initial velocity, the final velocity, the time, so V final equals V initial plus AT. V final is 0, initial velocity is 14, acceleration we don't know, the time is 0.1 second. So the acceleration is negative 14 over 0.1 gives you negative 140 meter per second square, and the negative here, it's slowing down. The object slows down because of the accident. Then the force equals mass times acceleration. So the force is the mass of the object, which is 70, times the acceleration, which is negative 140. You can remove the negative if you want, because it just indicates the direction of the force and the direction of acceleration, which we don't need it here. So it's 70 times 140 gives you 9,800 Newton. So number A is the right answer. So this is the first method. What is the second method? We can use the method of impulse and momentum. The force times delta T, this is the impulse, equals the change in momentum. So it's m v final minus m v initial. F is the required, which we don't know. Time is 0.1 second. The mass, we can take it common factor, which is 70. V final is 0 minus V initial is 14. And let's substitute here, so it will be 70 times negative 14 divided by 0.1. It gives you negative 9,800 Newton. Again, the sign here, it shows only the direction, but he is asking for the value. So the value is 9,800. So you can solve it using Newton's second law or using the impulse and momentum equation. A roller coaster goes around a vertical loop with just enough velocity to keep it on the track. At which position is the force of gravity? The force of gravity is the weight. At which position the force of gravity is the force of gravity the centripetal force? So at which position the weight will be the centripetal force? Let's see. In this position number 1, the forces are weight downward and normal reaction upward. In the third position, we have weight downward and normal reaction upward. In number 4, the weight will be downward, the normal reaction is perpendicular to the surface. In number 2, we have the weight downward and the normal reaction perpendicular to the surface. So what is the direction of the centripetal force? The centripetal force always directed toward the center of the circle. So in position 1, it's up. In position 2, it's to the left. In position 3, it's downward. In position 4, it's to the east. So which one matches the weight? In number 3, the centripetal force here is represented by the weight. So I will choose number 3.